Hey everyone, सबसे पहले तो यार साउंड चेक कर लेते हैं. माइक चेक. Can you guys write like +1, -1, confirming that sound is working fine? Yes, Thor. We'll start from basics today, and that is the goal basically. Like for someone like who don't know much about time complexity and maths for CP, they have like decent idea. That is the main goal. Mic is working fine. All right, guys, awesome. Just wait for 2-3 minutes. Let's start from 8:40 से start करते हैं. ठीक है. Let's wait for 3 minutes. Let me set up my whiteboard meanwhile. So like this is the agenda for today. After this session, like you should know the basics of time complexity. Like what do you mean by time complexity? Why does it matter? And after that second half, may like we will try to cover maths for CP. We'll start from number theory basics and then modular arithmetic. Combinatorics, I wrote it here, but we will say depending on time. At least session will go like for 1.5 hours. Yeah. So like depending on how much time we have left, we will do. Harish, I did not give the today's lead code contest. My friend can't use the chat. So they actually today I turned on the subscriber mode. So like they can subscribe. Probably they are not subscribed to the channel. That's why they can't see. Like within 1 minute after that they will be able to use the chat. As I know time complexity should have watched this class. So as you can see, like in the first half of the session, we will cover the time complexity. Second half will be about getting started with basics of math. And by the way, like for time complexity, like we will cover like lots of hands-on example. So the best part would be like for the folks like who think they know, they can at least look at that session. And so we will look at the example, then I will give you guys time to basically like try to tell me the answer. After that, I will tell the answer. Slides will be given. There are not many slides. So not just 2-3 slides are there. Most of the things are like I will write on whiteboard or I'll show you guys my code snippets and then I will ask you guys like what is the time complexity of this. Correct, Shivam. Problem in time complexity come when there are nested loops. Yes. Yeah, definitely. That's a good great book. Rhythm, today we'll mostly focus on time complexity. In one of the feature session, maybe we can cover the space complexity as well. But yeah, generally, I mean, time complexity is much more like broader compared to space complexity. Okay, guys, I think yeah, we are at time, so let's get started. All right, so before we start, like just 2-3 things. First thing is that like try to have focus attention. That is a general thing. But yeah, like I will try to like teach from the basics. And second one is that like after finishing every like subpart, let's say after every 10-15 minutes, I will try to like stop for doubts and take doubts from the last 15 minutes part. But in case you have some very specific doubts which you think most of the people won't have, or you are and like some specific doubt from maybe something you did in past or like what we taught, then in the end also we'll have like some time separate for asking doubt. So like don't worry about that. And the third one is that focus on fundamental. Let's say like whatever you talk about, right? That is general advice, like from my side. Like focus on fundamentals. In case something you feel some high level thing you're not able to understand, that is fine. Like sometimes you cannot grasp everything like in one go, but as long as your fundamentals are good or you understood the core concept, you are on a great path. Yes, so this is the last class, like from my side at least. uh, uh yeah, this is the last class from my side on YouTube. There will be one more class from Vivek, I think, on Thursday. After that, everything will be on Zoom, and like only the people who have joined the camp will be able to join. All right. So first of all, like, did you guys see? So I started a poll here. So let's get started. That is the first question, right? I mean, what is time complexity, and even more important than that, why should we understand time complexity? I mean, why does that matter? Can you check the subscriber time for chat? Time is 1 minute, Xful. Probably like they are not like logged in or something. Yeah, I think maybe they are not logged in. That's why they are not able to see. Okay, let me share the other tab and let's get started. You guys can see the whiteboard, right? Correct. All right. So, like I asked the question, what is time complexity? And today we will talk in like super basic, so that the people who are just starting with competitive programming, who are like literal at zero, they understand. So that is the those people are the goal of this campaign in general, like this session also. So like for maths part also today we'll start with very basic. I think let's say like in week 4 or week 5, like we can have a advanced math session also. Like during that session we can cover more difficult concepts. What is time complexity and why? All right. So first of all, what is time complexity? How long is the class? Class will be of like close to 1.5 hours at least. Okay. So time complexity is a way to basically understand like when our input size increases, how much time, like how would our time increase. So let me give an example. It is a rate of increase of time with input size. Don't get frightened. Let me give an example. Let's say our time complexity is O. So yeah, one more thing is that we'll talk about the practical aspect of like what time complexity mean in context of the CP. Like so this O of n, right? Like this is called big O notation. There is a like theoretical aspect to also read like how it is like defined in mathematical terms. So like we won't go into that at least for the beginner lecture. Okay, so let's assume hypothetical. We have a time complexity of O of n. Just think, forget the O actually. Let's just think our time complexity is n. Let's say it is the measure of number of operation our program takes. So if I tell you, okay, for your program takes n number of operation, and when n is 100, your program takes 5 milliseconds. So like let's say if n become 1000, how much time program will take? So like during the time complexity part, I will stop at multiple point and I will ask you guys to answer. And after that, we'll have lots of examples also. So that whenever I ask something, try to answer in chat so that I know you are on the same page. Correct, correct. 50 ms. Ronak is saying 10 ms. Ronak, why do you think this would be 10 ms? Okay, double D also saying 10 ms. Most of you are saying correct. By the way, even if you know the answer for sure, try to answer in chat. It will let me know like how much you are understanding. 50-50. So yeah, most of the people are correct. So that is the goal of the time complexity. So that it tells us how our time will increase with respect to the input size increase. So if we are increasing input size as 10 and we say our code takes O n time, so like we will multiply it by 10. If the size is increasing by 10, then the time complexity will increase by 10 only. Just wait a second. I think there is some lag with the whiteboard. Yes, this is correct. Linearly time increase करेगा जैसे input बढ़ेगा because your time complexity is open. All right. Now the same thing, but now what I'm saying, our time complexity is, or forget the time complexity. Similarly, let's say now I'm saying our code takes n square time. So n is equal to 100. It's taking 5 milliseconds. Now n became 1000. How much time will it take now? Yes. So Abdullah, this is 50 because we are increasing input by 10 times. So when we increase input by 10 times, it goes like the time was 5 milliseconds first. The time will also increase by 10 because our time complexity depends on n. Cool. Yeah, so now tell for this. We are increasing n by 10 times, but now our time complexity is n square. So if we increase n by 10, which basically means we do n into 10n, right? So let's say if we do like this, 10n into 10n, right? When we increase n by 10, it means doing like this, right? So 10 here, 10 here. Total, this would be 100. So when we increase n by 10, our time will increase by 100 times because it depends on n square, right? So this will become 500 ms. Correct. Yeah, most of you are getting very right. Correct. This is absolutely right. Correct. Correct. Everyone understood this, right? So this is the general goal. Basically, when we try to find time complexity, we try to have a measure of how time will increase with respect to this. So that let's say like you get so like this query, I get a lot of time. But yeah, I solved this problem. I got the solution, but I'm getting TLE. TLE means time like time limit exceeded. That happens because like when like lot of beginners, they are not able to judge the time complexity of their solution. So like they actually have to write the code and submit the code, and then they know this is exceeding time limit. That is the main goal of understanding time complexity, so that we can tell this beforehand whether our code is going to work or not. Okay, let me repeat it one more time. For all right, so let's see here. N is equal to 100, okay, and it takes 5 ms. Correct. Now we are saying, what if, and we are saying in our program we do n square operations. So like when we increase n by 10 times, our operations increase by 100 times, right? Like we have shown here. And in the same way, Abhinav also shared with us. So when we increase n by 10 times, our program depends on n square. So that number of operation increase by 100 times. That is the square of 10, right? That's why, like with n is equal to 100, time was 5 milliseconds. But when n increases by 10 times, time increases by 100 times because it depends on n square. Let's say if it would have depended on n cube, so in that scenario, in the similar way, time would have increased by 10 cube times. Correct? This is just an example. What's PW Army? Yeah, so 10 times was just an example to tell you like why do we learn about time complexity, so that we can understand like how our program's time will increase. Just to give an idea like why it will increase. Okay. So now we understand like the basic idea of time complexity. That is the main idea. We want to judge so that when we see a program, we can judge whether it will pass or not. All right. Now we move to the next part. Okay. Yes, ms means millisecond. Okay, now that is the one part. Now I will tell you one competitive programming part. Okay, so this part we understand. Let's say our time complexity O1 square. But then how do we actually understand whether our time will, like whether our program will pass in time or not? So in general, on most of the competitive programming platforms we code on, in 1 second, we can do up to the 10 to the power 8 operations. On some places, actually, we can do a little bit more than that, but 10 to the power is 8 is a very reasonable number. What is the significance of this 10 to the power 8? Because when we write a program, we can calculate how much time our program will take, and then we can compare it with this 10 to the power 8 so that we know whether this program will pass or not. Just to give an example, let's say my program's time complexity is n to the power cubed, which is n into n into n. And in our constants, we are given n is equal to 100. So that we know our program will take 100 raised to the power 3 times, which is 10 to the power 6. So because we know this factor, we can compare 10 to the power 6 with 10 to the power 8, and that would tell us, okay, our program is good enough. Our program will pass. Did you guys get this part? After that, we will go to like, how do we actually calculate time complexities? All right. So basically, goal is like whenever you do a competitive programming contest, right? On the top, they will tell you how much time your program is given, so that your program is allowed to run. Let's say if they say, okay, you are given 1 second. So on most of the platforms like Code Forces, let's say, in 1 second you can do up to the 10 to the power 8 operations. So whenever we write a code, we can calculate the time complexity of that code, so that we can calculate number of operations it will take on average, and then we compare it with 10 to the power 8. If it is less than 10 to the power 8, then we know like this program will run within the time. Let's say for this example only, right? If maximum value of n would have been 1000, then it would be 1000 into 3, which would be 10 to the power 9. Then we would think, oh, probably like this may not work, because I mean it is more than 10 to the power 8 operation. And correct. So the goal is so that calculate your time complexity and then compare it with the 10 to the power 8 one, so that you know whether the program will be correct or not. Correct. This is right. So if the n is maximum 1000, 10 to the power 9 operation, that will take like 10 seconds. And in our problem, we have time constants given. So if that is 1 second, so that it won't work. Yes, this is absolutely correct. Like after doing like how to calculate time calculations, right? So if you know how to calculate time complexity, then inputs can also give you some hint. If it is 10 to the power 4, then you know, okay, n square is the maximum which would work. If it is 10 to the power 6, then you can say n log n. Yeah, this is a good question. Like, what if time is 2 seconds? So in 1 second, we can do 10 to the power 8 operations. So in 2 seconds, we can do 2 into 10 to the power 8 operations. So we compare our time complexity with that. No Captain Coder. So that if I have 2 seconds, in 1 second it does only 10 to the power 8, right? So in 2 seconds it will get multiplied by 2. So in 2 seconds we can just do 2 into 10 to the power 8. All right. Now some rules about like how, when we calculate time complexity, what do we focus on? This part is clear to everyone, right? Give me a +1 if this is clear. Yes, time limit is for all the test cases. Basically, your whole program have to run within that. All right, all right. I think, sir, why n is 100? There is no reason, Shubhashis. I was just giving an example. If n is 100, how do we calculate the time complexity of the operation? N would be given in the program. What is the maximum value of n? There is no reason why it is 100. It was just an example to showcase how to calculate. All right. Now we will correct Shivans. That is correct. Now we will talk about like some rules basically when we are calculating time complexity, what to ignore or what to take in care, what to like take in consideration. After that, we'll do lots of example, and I think it will be a lot of fun. Okay. So one thing is, let's say your so like time complexity is O of n square by n. I can write this O of n, O of n square, sorry. This is important to understand. Like basically I can write it this. Can like someone tell me like why we can do that? So that like we said, right? Goal of time complexity is to have an idea. To have an idea whether a program is good enough to pass within time or not. But we are not calculating the exact number of operations it could take. This will become clear. Okay. Let's say n is 10. Then how many operations are these? 100 plus 10. 110, right? If it is 100, it will be 10 to the power 4 plus 100, which is 100, 100. Correct, right? Hmm. Correct. If n is 10 to the power 3, then it would become 10 to the power 6 plus 1000. Yeah, so from this you can see it, right? Like, as we are increasing the value of n more and more, the so contribution of this plus n, right? Contribution of this plus n is becoming less and less significant. Like for this part, contribution of n was 10%, but then it became 1%. Then it became even less than that. So you understand the goal, right? Basically, the goal of calculating time complexity is we want to have an estimate so that we don't care about the exact operations. When we increase the value of n more and more, then this value of n scale becomes more and more prominent. So n becomes more and more irrelevant for our total calculations. Because let's say like for the last one, if we can do 10 to the power 6 operations, then 10 to the power 3 is nothing. We can definitely do 10 to the power 3 operations as well. So that we can ignore this part. And n square plus n, we can just write O(n) square. For like more, uh, okay, I want to make a graph, but if you don't understand the graph, don't worry. I just want to make to show actually, but at a later time you'll understand. Okay, so this is n, and the y-axis is the number of operations taken. So for n, it will be like this, but for n square, this graph will go above. So as value of n becomes more and more, n squares become larger and larger, and n remains very small, so that it doesn't matter. Don't get scared of the graph, but did you understand like why can we write O(n) square plus n is equal to O(n) square? If anyone did not understand that, then let me know. Similarly, when we have O(n) square plus 10, we can write that as the O(n) square as well. Same argument, exactly same argument. 10 would become small and small as n becomes large and large. Exactly same result. Cool. Same goes with 2n also. Same goes with 2n also. We can write that as n, because just to give an example, let's say like we were discussing in the last part, right? If we can do 10 to the power 7 operation, then we would be able to do 2 into 10 to the power 7 operations also in most cases. So like the constant multiplier also we can remove in most cases. But in like some cases, we have to consider that. When we go to the examples, I will tell you when we have to consider. Correct, Kishanjan. O(n) square plus 2n also we can write. So like Kishanjan is asking, O(n) square plus 2n, we can write O(n) as well. But in some scenarios, we may have to look at the this two constant that is there. When we will go to examples, I will explain that in detail, like when we have to get there. All right, so everyone is ready to go to the examples now. Give me +1, then I will share my like code editor, and there we will look at the examples. Yeah, and like I would really ask you for the examples part, right? I have at least 10, 12 examples, and maybe on the fly, if you guys have a doubt about something, I will write an example, new example also. Correct, correct, correct. This was a typo. It should be O(n) square. Yeah, so for the examples part, after every example, even if you know the show for sure, try to write in the chat. Like, because the thing is that when we make notes or when we write, right, I believe then we understand it better rather than like just listening to it purely. At least that tactic works for me personally. Like when I'm sort of doing writing it or like doing something about it, then I'm able to understand it better rather than like just listening it purely. All right, I am opening my editor. Just give me a second, then I'll share my screen for you. But yeah, guys, like generally also like this technique works pretty well. Like whenever you're trying listening to some lecture or something, try to make something out of it. Like write at least some bullet points, small things, something. Okay. Can you guys see my editor screen? Let me know. Not yet. Okay. Can you see now? And can you see screen now? And moreover, like if you know if the size is very small, let me know. I will zoom it out. Size is fine, right? Like zoom is not needed, huh? Sidan, yeah, Dave. I sometimes use light mode, sometimes dark mode, based on that. But like for this presentation, I chose light mode because uh, yeah, because whiteboard is light, so that if I change again and again white to black, black to white, then it will become much more difficult. Is it fine now? zoomed it by one space. Is this fine now? यार लाइट मोड चेंज करते वक्त तुम लोग को ही दिक्कत होगी like when I change to whiteboard then you will have to adjust again. Yeah, so earlier I used to use Sublime Text. Now since last 1-2 years I'm using VS Code. And by the way, like on my channel I have a video about like how does my competitive programming setup looks. Okay, so now let's focus on the time complexity part. There are other questions you guys are asking that we can take at the end. All right, so for the first one, what will be the time complexity? Okay, and so this work done in O1, right? I mean, it just means work done in constant time. Like you can think, let's say we have a and we are doing a plus equals to 5. Like something simple, some simple operation we are doing. So what would be the time complexity of this? And for the next 15 minutes, please, even if you are sure, right answer for each and everyone. I promise that helps in understanding solutions better. And if you are not able to understand, you can write also, because I mean, don't think that okay, everyone knows the answer. I am the only one I don't answer. Class is to teach everyone. That is the goal. Okay, so for this one, everyone seems to have the answer. This is ON. Why? Because this loop will go on ON times, and inside we are doing constant time operation. So how do we calculate the time complexity of loops ON and whatever we are doing inside, which is in this case constant time, so it becomes ON. Correct? All right, this is clear to everyone. Let's go to the next one. What will be the time complexity of this? So for the beginners, right, we use the same approach. Don't get threatened by or like scared by oh my god, 2 loops are there. How do I calculate now? We first look at the one loop. We do this same thing. On into whatever we are doing inside loop. So what we are doing inside loop, there is one more loop, and this is the same as the previous one. So this is also ON. So the complexity is, everyone is understanding, correct? Awesome. So the complexity will be ON square. Just these things, how does this thing work? Like you have to think at the abstract level. Okay, don't get 3 loop, 4 loop, doesn't matter. Just use this simple thing. Okay, ON, we first look at the loop and then we are like, okay, what's happening inside the loop? That is again ON. So then total complexity is ON square. PWR. Very must. All right, let's go to this one. Now what happens? What would be the time complexity of this? Let's see. भाई others तो next level है. Others तो like mathematical notation में ही ले आया भाई वाह. All right, so again we will use the same argument, correct? Which is ON square into whatever we are doing inside the loop. Then there is again one more loop. Inside that also we are, every time we were doing O1, right? Which is a way of saying constant time, like 2 operations, 5 operations. But here we are saying work done in OM, which is like M is one more variable And with respect to that, okay, some people are saying n square plus m. Okay, see this. Then after, see, for outside two loops, we know that time complexity is O(n) square. So we will just think in steps. How do we know that? From the previous one. These are two loops. After that, after these two loops, we will multiply it by whatever we are doing inside. Why? Because these two loops are going on n square times, and then we are saying do this work n square times. This work will be done each and every time, right? So we will multiply this by work done inside. That's why it will be O(n) square into m. Because thing is that outside loop is n square, right? And this work is inside the innermost loop. So the total time is n square into m. Is it clear to everyone? Especially to the folks like who wrote n square plus m. Can you guys answer, Suraj? Can you reply? Did you understand it now? Correct, yeah. Captain Coder, everything will be shared. Don't worry. Now focus on class. After the class, ask me. I will share it. Yes. So the goal is that in the end, we are trying to, with the time complexity, right? We are trying to calculate a approximate number of operations. Correct. So we are saying, if we are saying run this loop n square, and what's happening inside the loop. So essentially, we are saying do this work n square times. Correct. In the end, there is some work we are doing it n square time, so that it will be multiplied, right? Yeah, I will show an example of plus m also. That is a good thing, actually. Let's show an example of plus m. Let's change this a little bit. Okay, let's say this is O1 only, and here we have work done in O1. Now what will be the time complexity of this? Look at this example, it will become clear. Tell me the answer for this. Others, for most of the scenarios, we should focus on the bigger term, which is n square. But in some scenarios, which I will take in that, we will see how it's matter. All right. Okay. Some people are saying doing it correct, but some are not saying it right. Interesting. Yeah. Many folks are correct. Again, we go step by step. Okay. On is the innermost loop is on, and then what we are doing inside the innermost loop. First, we are doing OM work. This innermost loop, this is running ON times. And what is happening inside this? First OM, and then there is one more loop, which is ON. Correct? That's why it's become n cross m plus n, which we can also write as ON cross m plus n square. Understood? Yes, sure. It depends on which is bigger, but when it's variable, right, we will include both of those terms. Because when it's variable, we don't know what could be bigger. So that we calculate time complexity in terms of all the variable aspects. Yes, just Raj. So plus इसलिए हुआ because look here. Let's take an example. Let's say there is a loop and someone's tell you wash clothes and clean room. So if this loop is running n times, someone is saying wash clothes n time, and then they are saying clean room n times. That's why we are saying this first variable is for how many times first loop is running, and then we are saying okay, this loop is running n times, and we are saying whatever is inside the loop, do that work n times. So we will multiply this by n, and then inside the loop, this is first work, this is equivalent to wash clothes, this is clean room. So that's why plus on plus on. Yes, others. Good question. I actually I have an example exactly like this. It will get answered. Clear, right? Should we move to the next example? Awesome. Let's move to the next example. Okay. Now we are getting in little bit the difficult territory. So for someone who is basically who got to know about time complexity first time, right? Few of the examples in the part now you may not understand, although I will explain it from scratch. But even if you don't understand some things, it is fine. Focus on the fundamental. What is time complexity? Why does we need it? And what is the way to explain it? But I will try. I think most people should understand everything. Like I will tell in exact detail. Yeah, so for try for this one, just look here. The main part is this. External loop is normal. That is the main part. That is the different part here. So like first thing is that try to calculate number of times both loops will run. So that I mean the whatever is inside here, how many times that will be executed that operation. Try to calculate the number of operations basically. Like that's how we think about these things. Awesome, awesome. And do right answers. Everyone write answers. Just Ronak. That is a good technique. Okay. So we will try to calculate it. All right. So when I is equal to 1, j will run one time, right? Second loop will run one time because it is always less than 1. Then when it is 2, it will run 2 times, 3 times, 4 times like this, right? And it will go up to n. And what is that? We know that is equal to n into n plus 1 by 2. If you don't know that, it is an arithmetic progression. You can calculate it using the formula of arithmetic progression. Correct? So when I is 1, in inner loop runs for 1 time. When it's 2, it runs for 2 times. When it's 3, it runs for 3 times. Correct? So total this many times we are running. And like we said, right, for time complexity calculation, we can remove the constants. So it will become O of n square. You can think like this. First, let's say it will become n into n plus 1. We removed the 2, and then we removed the 1 also. So it became O n square. Is it clear to everyone? Just write a plus 1, then we will move to the next example. So in general, many techniques we will cover, like how do we always things may not be that simple that we can just look at the program and say, oh, this is a time complexity. Sometimes like we may have to calculate time complexity by using different techniques like this. And some techniques are like very hard or very advanced also, which you can learn with time. Correct, Deepak? So it will be O of n square. No, Krishikesh. So the thing is that here in this example, right, we don't know how many times inner loop is running. So in the end, we are trying to calculate how many times this we go here. This operation is done. But the inner loop depends on I. So like we can't just calculate it. So by this, we are calculating how many times we will reach at this position. That's what we are trying to calculate. So first one we know for n times it will run, but this one depends on R. That's why we are trying to calculate how many times we will come here, and that is the way. If this is one, this will run one time. So in the end, how many times this will run in total, not just one time, in total, and how many times, like as a consequence, we will come here. Okay, understood. So this will get answered in later part. Generally we have to focus on the larger power. Let's say n square is there, we can ignore n, but in some cases we may have to consider these constant and everything. Correct. This is a good question. Can people try to answer? In this scenario, what if the work done is OM? So let's change this. What if the work done is OM? What happens now? This is a great question, Shubhashish. So let's try to find the answer. So we know loop is running one square time, right? So whatever is happening inside, we will just multiply it by that. Why? Because loop runs one square time, and then inside both loops we are doing OM work. So it will be ON square into OM. And by the way, like in like theoretically, like we don't write like this, like the big one notation, but for like practical purposes, I'm writing like this so that you guys can understand, which is fine. It doesn't. So the time complexity will be this. All right, this is clear. Plus one, minus one. Let's go, folks. Plus one, minus one, shown plus one, minus one, then we'll move to the next example. Next example is even little tougher, but don't worry. See, the point is that many things are advanced. I mean, but in general, beginner level, advanced level, there is no absolute meaning. It's just like which level are you at. So if you understood till level X, then for you X plus 5 is advanced. But someone who is at X plus 10, for them it is beginner. There is some absolute level, but when you actually incrementally increase your level, something something which felt like super advanced at some point, that would start feeling like very beginner to you when you actually. Correct. So yeah, Abhinav, let's go. Yes, आकाश we will cover math. At least हाँ अभी लग रहा है उतना पूरा कवर नहीं हो पाएगा, but at least we will नंबर थ्योरी तो कवर करेंगे, प्राइम्स नंबर थ्योरी वगैरह, levels of okay. What about this, guys? Let's try to find now. बताओ, this is a like little bit challenging one, but I mean it can be done. But if you're not able to do it, don't worry. It is little bit hard, I know. But try to think. So what you are doing here, okay? I starts from 1, then we increment I, and sum starts from 0, but we stop the loop when sum is equal sum less than n. We are adding I to the sum, but we stop the loop when sum is less than equal to n. So try to calculate for this. Some are correct, some are wrong, but I won't tell who is right, who is wrong. Like at least now I will explain, then I will tell. But yeah, some answers are right. Kudos to the people like who are giving the right answer. But it's fine. Or not able to understand. After this, you will get it. Okay. So in the previous one, right, we learned a new technique. Correct. How do we calculate it? It was a new technique. Till now, we are just doing, okay, how many times this loop that way. We learned a new technique. In this one also, we will learn something. All right. So idea is in the end, the goal is same. We want to calculate how many times this loop is run. That will be the time complexity. And this loop will stop when sum is less than equal to n. So let's say I'm saying loop will run k times. Okay, like I'm saying k times. Now we'll try to calculate the value of k, but I'm saying k times. Okay, in the when loop runs for first time, sum is 0. After one iteration, sum becomes 1. Correct? After 2 iteration, we add 2 to it, sum becomes 3. Then we add 3 to it, sum becomes 6. Then we add 10, sum becomes 10. Correct? So basically, it needs to stop when sum becomes more than n. Can you guys try to answer now? Like that was a big hint. But at least we can say it's not on, right? Because just after 4 iterations, sum is 10. So it's not n, right? I mean, that we can already feel that it will stop way before 10. Can you try to guess like what would it be? So yeah, one hint is that what we use here, right? This is the same. If the loop runs k times, then what I am saying, 1 plus 2 plus 3 plus k, that is equal to n, right? And for the first half, we can use the formula, which is k by k to n. So if we try to calculate this equation, when it becomes equal, let's say, so we just want to know the approximation, right? So we can remove the constants is equal to n. Then what is k? Square root of n. Correct? So the loop will run square root of n times. And that would be the time complexity of it. Did everyone understand? If you didn't understand, let me know. Is it clear? +1, -1. So what we did is that we assumed loop will run k times. Then we showed this. Okay, if loop is running k times, then after every time we are increasing sum by this element, and termination condition of this loop is sum becomes greater than n. So this have to be true. Then with the formula here, because we want the approximation, we remove the constants. Then we found out k is equal to square root of it. Do a +1 -1, guys. So that's the thing, right? I mean, if we, because we understand, we know how to calculate time complexity of this. If we see a code like this, we would be able to calculate by using the formula or some technique. Okay, this is square root n, so that we would know. If we didn't know this, we would be like, we would behave in a basic way. We would be like off, and then okay, if, let's say this is off, and we will think, oh, this program won't run, we will drop it. Awesome. Everyone have understood. Great. For the kth time, the loop will run. Yes, Mithilesh, that is correct. That's why, like, we said it here, right? But we just want to calculate the approximation. If we use this, all of these things, it will be like 2n plus 1, like root of that. But in the end, we just want the approximation, right? So that's why I remove the constant. Otherwise, you can keep the 2 there, 2n, then k square plus 1. It will be a quadratic equation, but the scale of it will be. Or let me quickly go over it one more time. So we want to calculate how many times this would run, and we assumed it would run k times. If it run k times, then this would be true. Why? Because in ith time we are adding I to the sum, correct? And loop will stop when sum becomes more than n. That's why others. Yeah, that's why Naveen. This will be true because it have to be n. Yes, so approximation, Shubhashish, basically it matters on, it goes back to like what we were looking at in the beginning, right? So the goal is that in the end, okay, if there is a big term, instead of k square plus n, if it would have been a big term, so we have to take that judgment based on that. And with time you get a feeling of more of that also. But yeah, in general, when you think something is not like non-dominant, then we can remove that. Yes, correct, Sanjay. All right, this is clear, right, guys? And like, I'm pretty sure like you must have learned something new from this. And these type of things, right? When you understand them, right, they increase your maths capability, like CP capability in general, because like your logic building is increasing and how you think about the solutions. Give me a plus one. Kushil, work is just, it's like number of operations we are doing inside it. Or let's say instead of this, you could have write constant operation. Or we can remove this also. That's the goal. Plus one. Cool, cool. Hardik, awesome. All right. Let's go to the next one. What about this? This is a simple one. Tell me this. Kushil, I will try to do it, yeah. I will try to do it at some point. Yes. ये वाले का फटाफट बताओ. Just tell me the answer of this very quickly. So the main part is that if we are doing I plus equal to 2, there is nothing different. Like all things are same, just the plus equal to 2 we are doing different. Okay, some folks are correct, some are wrong. Basically, it will be of. So see, first look here. How many times this loop will run? We are increasing it by 2, right? I will be 3, 3, 5, 7. So loop will run n by 2 times. So time complexity will be O of n, correct? like this won't be log n. We will show an example of log n also, but go to the fundamentals. Okay, how many times this loop is running? 1, 3, 5, 7, 9. So we are just skipping one number every time. So instead of n, this would do by n by 2. Give me +1. Everyone got it right? Understood. Okay. Now we are here. Now try to guess for this. Lokesh, for previous one, it is basically we are doing right. Value of I will be first, and after that we are adding plus equals to 2, right? Which means value of I becomes 3, then value of I become 5, 7, 9. So I start from 1 and it goes to n, and we are skipping every other number. So it means that instead of n times, it will go n by 2 times. If it would have been 3, then we'll skip every 2 numbers, so it will become n by 3. All right. For this one already I see like lot of answers. Let's go. Yes, Sanjay, that is correct. Hmm. Yes, most of you are saying correct, but some are just PWR में अब तो but yeah, most of you are correct, but some are wrong, but that is fine. We'll make it clear. But yeah, there is one thing which I generally also tell people a lot. Like in this exercise also, that's why I'm showing this example. Don't just focus on what is the time complexity of it. Like Joby, whatever these proofs I'm showing, right? These try to focus on the proofs as well. Because in the end, 15 examples teach you a lot, but the proofs you learn, with those you can solve 1500 example of similar things. So please focus on the proof, whatever I'm telling. Some parts, if I say, okay, this kind of script, that is okay. But whatever I'm explaining, try to understand the proofs. Okay, so in this one also, right? We will use a similar technique. First, I would be 1, correct? Then I would become 2, 4, 8, 16, 32. We can see that, right? After the ith term, I will be to the power I. So we will use the same technique. Let's say loop runs k times. So the loop will stop and to the power I will become more than n. Why? Because we have this condition. So if the loop run k times, after the kth term, I would be to the power k. That have to be greater than n. From this, if we take log on the both sides, k becomes log n. Base is 2 here, but yeah, if you don't understand the base, then just think log n. Correct. Correct. Is this clear? So, like from these two examples, you can see this, right? I mean, there is a general pattern which can be helpful many times. If you are not able to understand just by looking at the loop, then try to assume, okay, loop will run k times. Then you can do this like deduction, which is like, okay, loop will stop when it happens, then k is log n times, which means loop is running log n times, and which also means that complexity will be of log n. Abhishek Singh, so the point is that it is log of base 2 because this is also 2, right? but you can, that's why we took log of base 2. But you can just assume log of e in or whatever base you want, because in the end we can change the base by using the logarithmic formula, and the outside terms is a constant, so it doesn't matter, at least to reasonable extent. Or some 2 equal to k कैसे हुआ? Okay, yes, so Deepak, look here, we are short, right? We are multiplying I by 2 at every step. So after first step I equal to n, then I was 2, then I was 4. It is getting multiplied by 2 every time. So after ith step, it is 2 to the power I, correct? Here 2 to the power 2, 2 to the power 3, 2 to the power 4, to the power I. So if we say loop runs k times, then it is 2 to the power k after that, right? Is that clear, Deepak? Just Ronak, we have an example for this also. +1 -1 guys, +1 -1. Yes, that is correct. Okay, Abhinav's question is interesting. Can someone try to answer it based on what they've understood? What if I is equal to 0 here? Try to answer this. So the Abhinav point is, if I is equal to 0, right? After second term, it will 0, 0, 0, 0. Multiplying 0 by 2, it will always remain 0, right? So if, okay, if n is -1, then your loop will end initially. But otherwise, if n is any positive number, it will go in an infinite loop, because I will never change. All right, guys, just a like, so I have many more examples, but can you guys comment like, so this example showing whether it is feeling useful or not? I mean, maza aa raha hai? Are you guys having fun, and are you feeling like you're learning something? Because I have many more examples, so that if it is becoming boring, then we will skip and skip to the number theory part maybe. But I have many more examples. If it is fun, then we will continue with the examples only. And which is fine. If you are not able to cover maths, then it is okay. I mean, we won't try to like rush it. We will in the next session we will cover math. That is fine. Even if we have to take extra session, that is okay. Yes, Nimish Goel. So there are two. Yes, you are correct. It would be k+1, but like we show, right? I mean, if that is a constant term for the time complexity, it wouldn't matter. Yes, Shubhashi. So I is equal to 0, then it's infinite, right? But the point is that you don't have to calculate time complexity. You just know that program won't terminate. Or somewhere in there. अभी ना खाना खाते खाते कर लो यार dinner. What's that? ठीक है, let's go to the next example. What happens now? Now we change this. Aditya, not today, but in the camp we'll cover. Like eventually we will definitely. But manipulation, yeah, not sure actually. Like I'm not sure if this, like we can eventually cover it in the advanced topics, but before that, lots more topics are there. Logan, correct answer. Some answers are wrong also, but we'll correct it. But for this, can someone write like 4 or 5 words? Why Logan? We are starting from and now we are dividing. Why Logan? So like for this proof, right, I'll just tell you one interesting way of looking at problems. So that I mean it will be like really fun way of looking at problems. Correct, Simans, very correct. Yes. So for this one, right, I mean we can prove it in the same way. But look at this from this unique perspective. I mean, this is literally the same thing. We're just doing it in reverse. So अगर one से if नहीं, if it took us log n time from coming from 1 to n, then obviously n to 1 will also take log n time, right? I mean, constant time, it can take 1, 2 extra steps, less steps, but it will take us same time, right? So if we know that is log n, this is also log n. So like in general, like just a general comment. In general, these things, right? Symmetry. This is a symmetry. So that many times just by symmetry, like when you're proving something in a proof, like you use symmetry to like logic for something. Okay, this is correct. Agar if we came from here to here, this is log n. Obviously, backward number of steps will also be log n. What about this? Just just give an answer for this one quickly. This is simple, so we won't explain unless someone is not able to understand. Just for the reverse one, PW Army idea is that assume after k steps it became one or it became zero. So now you know n divided by to the power k is less than zero. Then the same argument flows. Okay, so for this one, everyone knows. So we are taking log n steps, and in every step we are doing om time so that it is m log n. All right. Now for this one. So this is called binary search, but it doesn't matter. If you don't understand what binary search is, we don't care. We will just try to use the application what we did here and find the solution of this. So this is called binary search, and at some point we will cover it also actually in great depth. This is one of the most useful algorithm. So like there is a joke, right? When someone is let's say at code forces like you're 10,000 and you are learning some very advanced topic, then someone will make a joke, then first learn binary search because that joke came from the idea that binary search is like super useful. It have application in so many things, and sometimes very high rated problems which would be like 2000 on code forces. Those kind of problems will be using binary search as the single concept. So binary search applications are huge in every area. All right. So for this one, can you try to find the answers? Like, how do you know Logan? Do you just remember it? So, by the way, proof of this is connected to the previous example. That's why I had examples in this order so that you can use the information you learned to basically learn the new one. Yes, very correct. Very correct. But in this one, right? I mean, we just showed this example, right? This is a one-liner and it is still the same. Why? Because look here, okay? When we started, low and high. Low is the lowest point, high is the maximum point, and we just loop terminates when till the point they are they converge. So let's say low is this, high is this. So at every point, this is becoming closer and closer. When we begin, it have n distance between them, right? High is n, log is n. And then we do mid. Mid is the middle point. And then based on the condition, we do this half. We either go to the left half or we go to the right half. So in the next step, it will be n by 2. Then it would be n by 4. Like we did this in simple example. This one-liner is equivalent to this. So like we proved, right? If it is going like this, then it would become O of n of log n. Correct? And let's say if it would have been m, then it would become O of m cross log n. +1 +1 -1. So +1 -1. Tell me +1 -1, guys. Then we'll move to the next one. Okay, so basically just wanted to flash this. It is like, I mean, just wanted to flash it and so that you guys are aware. At some point, maybe we can talk about like very advanced solutions. So like, this is a master's theorem is a way of like solving these recurrence. So in this case, we could see it directly, but what's happening is that T of n, then we are doing some constant work and reducing the search space in T of n by 2. So using master's theorem, we can actually prove this, but forget about it. Just wanted to flash that sometimes these, like, we are not able to solve these solutions. I mean, not this one, but sometimes the recursive solution may become very hard and we are not able to see like just by like looking at this. So in those scenarios, there are like mathematical theorems like this which can be used to solve it. I mean, maybe we can talk about them like sometimes in detail. Confused. Sherman, that is good to you're able to understand. Can you please help me with explaining on solution? All right. So the point is that we are doing this loop for log n times, correct? And then log n times we are doing the loop. And every time if we do the OM work, then it's like M get multiplied because loop runs log n times and then we are doing OM work every time. That's why it becomes M into log n. It's compared to the previous time how we were running the loop. And just to see a nice thing, right? I mean, I showed it by loop because we are learning from the loop perspective, but this is like a recursive, like this kind of thing will happen in the recursive also, right? We can write the same program in the recursive way also. And by the way, for solving recursive ones, this is very important. But yeah, maybe in later section we can have a like detailed sort of session to go in depth of these kind of things. What happens when the code becomes very hard? Then how do we calculate? Atik Patel, we will take the unrelated answers in that. Yeah, this is CEO of erroneous, but I mean we can skip this. I will explain this when we talk about maths number 12. And probably, yeah, I have some more examples of time complexity. Let's do this. Let me cover those examples. Then time complexity, you will be very good in time complexity if you have understood everything till now. And then maths, we won't be able to do, I think, for today. Because, you know, whatever I teach, I want that you actually understand. I don't want to just like rush through it for the sake of it. So if maths we start, I mean, we can't really get through anything. So we can take one extra session, which is completely fine. But yeah, some more examples PWRME I have. After that, for sometimes if you guys have doubts for this part, we can take those doubts. Or if you have general questions, we can answer those. For this one, yes, log of log n is there. But yeah, we will take it in when we talk about the maths in number 3. Okay, what about this? This is an interesting one, and this is like a completely different technique. I think examples would be done in 5-10 minutes. After that, we will take some. Yeah, just give me like a 1 minute break. Till then, tell me the answer for this. Okay, guys. So some people are telling correct answer, but like I want you to tell like 4 or 5 words also, like why what you're saying is correct. Like give some explanation also. But by the way, folks, if you're finding it useful, can you like the stream so that it goes to more people after 3 months? That would be useful. You guys can like it if it is useful. So loop to n times ही चलेगा. We'll see. We will see. Hmm. That is correct. N plus k. Yes. Yes, Sanjay. This is among us. So 2n is the right answer. Yeah, yeah. Just think for 1 minutes. So this is a difficult one, but you know these type of techniques they are super useful. And I will actually tell you one thing. Like in C++, one of the data structure use this kind of technique for doing something. Yes, many data structures, Sanjay. Actually, many. All right, now let's see. So we will try to use the same thing, right? We will try to use how many operations are happening. Okay, let's say this loop we know loop is running O(n) times. This we know this is running O(n) times. Okay, but what about this? This is not clear because you know when the conditions come right, things don't become things are not straightforward anymore. We can't just tell directly by looking at the code. When condition comes, we have to use logic like we have been using in past so many examples to tell. Okay, so this we know one time, but like we don't know like how many times this will do. Okay, let's try to make sense. So initially k is 1. So when we go into the first loop, I is equal to 1, I is not greater than k. So k is always greater than I, right? So in the first loop, it runs for 0 time. This one. We are trying to calculate the number of operations, okay? in the second time, now I is 2, that is greater than k. So what happens is that work done in OK, which means OK operations. Okay. Yeah. OK operations. Nice pun. Okay. Cool. So in the next one, it will be done OK time and k is now 2, which is, let's say, one operation. Then when I becomes 3, now I is 3, then k is 2. So again, k will be multiplied by 2, and we will do 2 operations. When I is 2, 0 operations, 0. Now when I is 4, k is 4, 0 operation. When I is 5, k is 4, we will do 4 operations and we will multiply by it. Correct? Okay, so this would be very this would be little difficult, but like this technique is very useful, not just in actually, like in many advanced kind of data structure also you will find use of this technique. So try to understand it. I will explain again actually if you don't get it in the first time, which is fine, but try to understand it. Okay, so can we see a pattern here? We are doing operations when k is equals to, we are doing 1 operations here, and then we did 2, then we did 4. So number of operations wise, we are doing 1, 2, 4, 8, 16, right? We'll keep on doing this. So we're just trying to calculate how many times we are going here. So when would this stop? This would stop at 2 to the power I, right? Because I mean, when 2 to the power I, which is k, it becomes larger than n, like I become larger than it, then it will stop. So to the power k, not k, let's use something else. To the power p. If we use p terms, now we are assuming that p terms are there, all right? Like we assumed in everything else. Cool. So, but I'm making a claim 2p is less than n or less than equal to, yeah, I mean, it feels like log n, right? But it's not the same. That's why I'm explaining it very slowly. So in here, p terms, but we know 2p is less than n, correct? Because at max, when I becomes greater than k, we are multiplying it by k by 2. So I can be at max n. So k can be at max 2n, right? Because if k becomes 2n, then I will never be greater than k, and we won't multiply it ever. So let's say we know the last term, okay? Now we know the last term, which is n. So this becomes a, and the previous term would be n by 2. I mean, so try to understand the like one nuance that it can be 2n or 1.5 and something like that, but it's okay. I mean, that is a constant time factor, right? So we can just say, okay, it isn't. Then previous term would be n by 2, term before then would be n by 4. So in the end, it becomes a geometric progression. So its sum is to the power n, not to the power n, 2n. I mean, it would be close to 2n. If it would have been infinite series, then it would be 2n. But yeah. So like, forget about the actual problem. Did you guys understand like how this is coming? +1, -1. Do you understand how the 2n thing? It is fine if you don't. We will explain it again. This is a bit difficult, but I thought this concept is so important, I should cover it. Yeah, like I understand. Okay, let's try a new technique. Okay, let's forget these three terms. Now we are starting from scratch. Just forget everything. Okay, now just look at this. We will go step by step. I will take plus minus one for step by step now. Okay, so this part is clear, right? K is equals to 1, and we are increasing k by 2, multiplying k by 2, and every step we do OK operations. Correct? So we know we do one operation at some point, then we do two operations because it depends on k, then we do 4, 8, 16. Can you tell me what is the largest term? Okay, forget even that actually. Is this part clear? Plus or minus 1 for this. Forget everything. Is this part clear? Plus or minus 1 for this. We will do one operation, then we will do two operations, 4, 8, 16. Because operations depend on, we are just trying to calculate how many times this thing will be done. And it depends on k, and we are multiplying k by 2. Plus or minus 1 of just this part. Forget the problem, just this okay part. Forget whatever I told before this. Just look at step by step. All right. Now try to guess what can be the last term of this. So this is geometric progression, right? What can be the greatest term in this series? Try to think that. It's fine. You can take some time. Try to think that. This is, I wrote here 2n, but it can be wrong. Let's say it would be 2n, but try to think what could it be. Just the correct. Do you guys understand why this would be n? Because k can at max be 2n, right? Because in the, let's say I is equal to n, then we doubled it. So, and but work done depends on, okay, first we do the work and then we are doubling it. So the operation is maximum n. Is this correct? Forget everything. I'm just saying number of operations done in this line, the maximum value of this series will be at max n. So plus or minus 1 for this part. Okay, so we do, let's forget this actually, right? Do operations k times. Okay, so we are just trying to calculate the number of operations. So this k would keep on increasing, 1, 2, 4, 8. So in the same way, 1, 2, 4, 8. If at any point this k became n, then this if condition can never be true because I is at max n. So I can never be more than k. If k became n, I can never be more than k. So this condition will never be true. So we would never come inside this loop. That's why this term would be at max n. Plus minus 1 now. After that, I thought of a nice technique which will help you in understanding the solution after this. Plus minus 1. Awesome. All right. So now I'm telling this thing. Okay, it's n just reverse this. I'm just reversing this, reversing this series. N by 2, right? Previous term will be n by 2 because it's getting multiplied by 2 at every step. N by 4, n by 8. So can you calculate the sum of this series? Now forget everything. We're just focusing. Can you calculate the sum of this series? What would be the sum of this series? This is geometric series. Forget about the problem, time complexity. That's how we do it. Just focus on this part. Don't care how the time complexity will come or whatever that is. Yes, this is geometric progression. What will be the sum of this series? Let's say I tell this is going up to infinite because eventually it will become zero, right? 1 by 2 is 0. Or you can say 0.5 or something like that. All right, so this would be 2n. Is it clear to everyone why is it 2n? It's a geometric series. You can use the formula a over 1 by r, 1 minus r. A is n, 1 minus r. R is 1 by 2, which means 2 minus 1. Then 2 goes above, which is 2n. So yeah, so thing is that if you don't understand this, you can search geometric series, and for infinite series, when the formula is this, which would become a is the first term, so it will become 1 minus half is our difference, so it will come as 2. Yes, this is the formula which is geometric progression for infinite. Like I thought in this way you would understand this somewhat better. Okay, now plus minus 1. How it came to n, is it clear? So we have calculated number of operations in total are 2n plus minus 1. Is it clear? Forget about the problem. Is 2n clear? Awesome. Awesome. So we calculated, right? We calculated total number of operations. That's it. I mean, there's nothing else to do. We calculated number of operations. That's what we wanted to calculate. So yes, 2n is the number of operations. Time complexity will be 2n, which we know we can write as O of n. Siddhan, maths, we will have a differentiation for maths because I want you guys to understand. I don't want to like just through the topics. Math now we can't do today. Cool. So that's it. Time complexity of this is O n, right? I mean, when you were looking, right, it didn't look O n, but yes, Lokesh question is outer loop. So Lokesh, the point is that this loop is running n times, right? But in the end, because we couldn't just see based on the outer loop, that's why like we are actually calculating how many times this operation will happen. Outer loop is also n, right? But we calculated how many times this operation will happen in total. So I mean, you can say plus on for the outer loop as well, but in total it will be on still, right? Yes, sir. Yeah, actually, yeah, I will share it. I can share the code. Yeah, so okay, so this we calculated, right? This is called amortized time complexity. This outer loop question will become even more clear, which is a average time complexity, which means that for when the value of I is equal to 5, in that iteration of loop, we will do 4 operations. But when I is equal to 4, we will do 0 operations. So when we are iterating the outer loop n times, sometimes we are doing 4 operations, sometimes we are doing 0 operations. So like when in out of n iteration of the outer loop, few iterations will do a lot of work. 16 operation, 8 operations, like you're showing here, right? But many I values, we won't have to do any work. That's why like we calculate total number of operations, which is 2n. And things like this called amortized time complexity, which means that, okay, in one iteration, we can do, like we use this kind of thing in many cases where, okay, one query can take on time, but on an average, total time would be, let's say, 4n. So we say in general, it is a constant time. Just location, correct. So intermediate step is 0 operation, or we can add one operation, which would be n operations extra. So we are calculating for outer loop only, but like we showed here, right? Sometimes it's 0 operations, sometimes it's 4. So in the end, we calculate total number of operations we are doing. See, I understand this last example was a little bit hard, but it is okay. Just try to think it more. And if there is a doubt in the math section, when we cover maths, we can cover in the first 5 minutes again. See, I genuinely understand, like I was debating with myself whether I should like cover this or not, because the goal is like their beginning time complexity. But I genuinely think this kind of thing is an important factor. So I just wanted to cover it. But even if you don't understand now, just try to go to the stream once more or try to learn, and we can take doubts later. For other iterations, operations are 0 money. So I mean, you can think of it like that. Okay, 0. So what you can do is you can add 0 for other iterations, or you can add 1, which would be like extra n operations. Then it would still be over. Yes, correct, correct. This okay. So the point is that vector, yeah, vector uses vector is just one example. Many things uses for like these kind of things. So what vector does is that vector in vector you can do pushback, right? So like what happens is that when you are 10 elements, right? So sometimes vector would be having a array or like contiguous memory of size 16. When you put 17th element, vector will allocate a new memory of 32 elements. Like the exact number can differ based on the implementation we are looking, but then it will move forward. So the one pushback of 17th element that actually took 32 operations, but on an average it would be constant time, because if you put n elements, it would be like 2 and 3 and like we showed. But if there is a while loop, Prakash, yeah, it would still remain same. Yeah, that is a good question though. That is a good question. Try to think. Answer is that everything would remain same. While wouldn't change anything. So like in STL, many things where we use memory or something which we can change, these that things would be there. So one pushback can be like, okay, one pushback operation to 10 to the power 5 operation, what is going on? But on an average, it would be constant time, because for n pushes, it will take 2n time. Yes, complete code I will provide to you guys. I will think how to share, or maybe I'll just paste it to paste bin and I will share the paste bin with you guys. So don't worry about that. Okay, so one last thing. one last thing that I wanted to show you guys. Work done is equal to 5 operations. So the operations are 5n. So if n is 10, so we can ignore the constant. Wait a second. Yes, what I wanted to show is that for this case, we can just do open. Correct. Like in CP, these kind of things can matter. When we have 50 operation, probably we can still do. But what I wanted to show is that if for this case, if n is 10 to the power 5, then we are still fine, right? Because overall it would be 5 to 10 to the power 5. But let's say it's 50. Now if n is 10 to the power 5, overall it will become 50 into 10 to the power 5. Correct? So now this is mattering. When operations become 500, then what happens is that then it would become 500 into 10, which is 5 into 10 to the power 7. So I just wanted to show this. When constants are smaller, right? That's why we ignore the constants, because when constants are smaller, we can just ignore them. Because if we can do 10 to the power 5 operations, we can do 5 into 10 to the power 5 operations. But when our constants start becoming large and large, then we have to like put them in our calculations, because okay, it was 10 to the power 5, but the 500 operations it became disused. If it is 5,000, let's say constant is 5,000, then it would become 10 to the power 8, right? Which would go over limit of 10 to the power 8. So just wanted to say this like nuanced point. When constants become very large, then while doing your time complexity calculations, multiply constant value also to find total number of operations. Yes, Captain Coder. These kind of thing people call constant factor. All right, guys. So first of all, one thing, can you tell me the feedback about the today's session? Like, do you like this kind of session where I'm showing you examples and you can sort of try to first find it yourself, then I tell you the solution? Do you like this kind of format, hands-on format, or like do you just like the lecture kind of format where I'm just telling you this? Which format do you like personally? Awesome, Raj. ऐसा ऐसा कमेंट कर दिया करो यार, मजा आता है पढ़ के. Then it feels worth it actually. Question answer format सब कह रहे हैं interactive is better. Yeah, because I also think that, but I wanted feedback if people like the kind of lecture wala format. Yes, confused mom. So whiteboard also we will use. That is ऐसा नहीं है कि example वाले format के लिए we will use this only. But it depends on the जैसे number theory में we will use whiteboard and coding example both. हाँ मोहित वो करेंगे यार when we will do the practice one, but it depends on the lecture. Cool. Thank you, Hardik bhai. Thanks, game model. Rishabh, task will be on Slack. It will be posted on the Slack. Cool, Mohit. Thank you. So yeah, feels good. Matlab feels like everyone likes interactive session because like personally, I thought it should be more helpful because in general, in problem solving also, when you are solving a problem, when you think about it for some time, and either you're able to solve it, or when you're not able to solve it, right? In those cases, you understand the solution better, because if someone just tells you the solution, you generally don't learn much. But when your brain had to think, okay, maybe this is O(n) and log n, and after that you think the solution, then your brain connects more. Okay, I was doing that thing wrong. Then sort of your connections in your brain like becomes because of that. Which icon it is? Need extension in your editor. कौन सा वाला यार? Which one? Turn test cases. हाँ मेरे like anyone who wants to see anything about my editor or something, I have a video where I'm explaining my competitive program setup, which are the extension I use for things like that. Yes, Aditya, we will have a separate session format. Don't worry. Maybe in the next week we'll have. Code की tension मत लो. I will share आज या कल सुबह. I will share it. I will copy paste and I will share it. Don't worry. भैया एंड में कोड फोर्सेस क्वेश्चन का टाइम कॉम्प्लेक्सिटी कांस्टेंट समझा दो. ये करना है क्या गाइस? हाँ ये कर सकते हैं. रुको, लेट मी डू दिस. लेट मी ओपन कोड फोर्सेस एंड टेल की जैसे प्रॉब्लम देखते हैं तो हाउ वी हैव टू जस्ट लाइक व्हाट टू थिंक एज ए फर्स्ट. ये कर सकते हैं. Just how to read it actually. और yeah, now for next for 5-10 minutes, वीक में कितने दिन? हार्दिक 2 लेक्चर डेफिनेटली होंगे, बट अगर जैसे कभी रिक्वायरमेंट लगी तो ज्यादा भी कर सकते हैं अगर ऐसा लग रहा है कवर नहीं हुआ तो. ओके, cool. This is problem D from like contest from 3-4 days ago. So one thing is that whenever you open code forces, right, on the top you will see time limit per test. So this per test mean inside you will have test cases also, right? So per test just means like whole test. So they are not telling what each test case, like whole program should run within 2 seconds. So like if we use our logic, right, 1 second we can do 10 to the power 8 operation. So if we have 2 seconds, then we can do 2 to the power 1 second. Yeah. So if we have 1 second, we can do 10 to the power 8. If we have 2, we can do 2 multiplied by 10 to the power 8. So this problem solution we discussed, right? So the solution of this problem actually comes up. Yeah, this can be done in linear time. So the solution of this was O of n. And then you see, right, value of n. Okay, someone can think, okay, test cases are T O of n, then it is T into O of n. But in the end, they are saying guaranteed the sum of values of n over all test cases does not exist. So total sum of n is that. So if solution is O of n, total program will run O of n. So n is 10 to the power 5, 2 into 10 to the power 5. So we can see that is significantly lesser than 10 to the power 8 operations, which we can do 2 into 10 to the power 8 operations, which we can do in 2 seconds. So we know our solution for this will be fast. Others, which part is weird? Acha, problems mein, yeah, problem is weird. That I can agree. Yes, Mohit. We'll talk about this in detail. Also explain about judging. So the thing is that, let's say, if your solution is n square, it will take 4 into 10 to the power 10, right? Because n is this. For those cases, you are taking more operations than what you can do in 2 seconds. So you will get a time limit exceed error. Yes, meaning of guaranteed sum is that test cases can be different, but total sum of all the n in all the test cases, that will be less than this value. So that it means is that, okay, test cases are there, right? And in each test case, they are saying n is this. But they are telling sum of n over all test cases would be this. So if we have solution of O of n, we don't need to multiply that complexity by t, because total sum is this. TC निकालने के लिए ठीक है, तो next 3-4 मिनट we can take some question. Just let me come back. 5-10 minutes we can take general questions. After that we will close this thing. Okay. Akshay, let me tell you it. Sum of test cases means, let's say first test case n is 10, then in the second test case n is 20. So they are saying then n is 1000. They are saying sum of all of these things, sum of n is less than equals to 2 into 10 to the power 5. Which means whenever time complexity is on, we don't have to worry about this t, because n is up to this. If t is also 10 to the power 4, otherwise it would become very large, right? So they are guaranteeing that n, all sum of all n will be this. So that's why we can just simply say, we can ignore this t and say our program will run in on, which is like 210 to the power 5. That is the maximum number of operations we are doing. Let's take any questions. फिर for 5 minutes करते हैं, उसके बाद we'll close this thing. Yes. Yeah, so this question is Shivansh is a good question. So the thing is that when you're calculating number of operations, right, always take 10, 20, 50, always take it. If it is 2, 4, 5, then ignore. If it's 25, then take it. Because you know what happens is that sometimes your solution will go so close to the answer, then I mean it makes sense to, at least when you're submitting report. Yes, Mohit. So for this we will have a detailed video, but generally check how much time we spend on each program process. Okay, you will have to track actually. We want to, but if you're asking how much you should spend before looking at the solution, then generally like 25-30 minutes should be an average. But these things would vary based on how difficult the problem is, or like are you able to make any progress or not. Others, so it's like it more of a practice only. I mean, it's like I have been doing complete programming from solo. Like in the beginning, I was also not able to solve the simple problems. Yes, but the one thing that you guys can focus is that, so I've seen many people, they actually remembers, okay, n is, if n is 10 to the power 6, then n log n. You don't have to remember those things, okay? If you know this 10 to the power 8 rotations or 8 rotations are there, then you can just calculate it, right? You can just calculate it. If n is 1000, okay, n is 100, then we know n equal to 4 would be 10 to the power 8. So it will work, right? If n is 1000, then we know n square will work. So if you understand the fundamentals, you don't have to remember those things. If n is 1 is 7, 1 is 7 basically means 10 to the power 7, then we know O n would work. So those things, if you understand the problem, then you can just do it. Abhishek Singh, how do you read a CP problem? Yeah, I can make something on it, but like I can't tell anything immediately which would be helpful to you, but I can make like a short summary or like short text on it. In general, yeah, maths, we are getting many questions how much math is required and all. So in general, if you know school maths, that is super useful. School maths ka everything is useful, but topics wise, number theory, modular arithmetic, and third is combinatorics. These two topics that I will plan to cover, at least in the getting started with maths version. Those are the three topics which are most useful, at least to up to a very good level. You can say 1700, like 1800 level. Till that level of code process also, those topics are the most important thing. And for time complexity also, most of the cases, whatever we learned today, you can find like time complexity by using those principles. If there are like some very advanced cases, I will try to cover that in future. But for problem of 1700, 1800, I think most likely 2000 getting problem 30, you should be able to find by using these logics. Abhishek Singh, yeah, I definitely like understand your point. Solution is work on the math problems. Whenever you learn about a new concept, like read about that concept. Incrementally, you have to build. That is the goal. Because in CP, math is important, no doubt. Like it is very important. CSES is famous for having standard problems, standard ideas. So if you leave the advanced section, if you cover everything except advanced, so not advanced, additional. I think except additional, if you cover everything, you would know most topics in CS, like CP, which are required to go up to master level or probably going grandmaster. I think topic wise at least, you would know most topics. Yes, whoever is, what are dearrangements? Yeah, we can talk about this in like combinatorics topic. Is it was it added good? Yeah, yeah, I'm not sure. Is it still available? I thought it got closed or something. It used to be quite good, but I'm not sure if today it will have very old problems or not. But it is still, it won't be like, it still won't be back. Just you can leave now. We You can leave. Topic is over. Make it for code forces guide for beginners. बना सकते हैं यार. You can do that. Sum at that. That's it. Like so, whoever's math is weak, what you have to do is, for any specific topic, try to solve more problems for that. And let's say you tried solving a problem, you thought for 25, 30 minutes, and then you found out you are not able to solve it. Then you're looking at the solution. While reading the solution, you saw a new word, factorial, or you saw NCR, modular arithmetic. Then take that word from that solution, problem solution, search it on Google, read about that. This should be the way. Like personally, I think that is a good way of incrementally improving. Also, you can try things like this. Okay, there is a math set on CSES. There is a math set. You can try those things to sort of like discover ideas, discover things. But yeah, In general, incrementally building is definitely a good method. Screencast कर सकते हैं screencast others, but I'm not sure whether screencast is useful or not. Like I have thought about it, but I'm not sure it actually helps. Like it's very cool. Like I've also seen screencasts of people, but I'm not sure how helpful it is. Cool, chalo. Guys, we will close this session for today. I hope it was useful, and see you guys in next session next week. Just Ronak, we'll see. Also, if you found it useful and haven't liked the stream, like kar do yaar. Alright, bye bye. See you guys.